Hello, and welcome back to Electrical Engineering. In the last episode, the question was asked whether or not current would flow in this circuit. Here is where I want to help you start thinking like an engineer. Without using much brain power, you might realize there are a couple of questions you should ask, like how much voltage is there? Kind of like your high school teacher. If there aren't any units, the answer is wrong. Well, if there is no amount of voltage, the question is also wrong. Next question, can current travel through the air? Now this is an important question. You might recall from episode 3 that I said current is constrained inside the wire. Well, actually, I wasn't quite honest with that statement. Most of the time, that is the case. Current cannot leave the wire. However, there are certain cases in which current can leave the wire. A spark plug might come to mind. We will actually figure out the answer to this question in a later video. I want to move on and continue looking at parallel and series components. Let's design a simple circuit, basically the same one we have been using. This circuit has one voltage source and one resistance source. We will give these components some values. The voltage source will be 3 volts and the resistance will be 6 ohms. There is a voltage source that will start pushing some current. We can calculate the amount of current by using the handy-dandy Ohm's law. We plug in the values, rearrange the equation to find the current, and solve. What we find is that there are 0.5 amps flowing in the circuit. Easy enough, right? What if there was not just a single resistor, but 2 in the circuit? How would we go about solving this circuit? If you remember back to a previous episode how we added 2 batteries together to get a sum total voltage, well, we can basically do the same thing with resistors when they are in series. Let's say these resistors are both 3 ohms apiece. Here's one way to think about it. Imagine that you are an electron traveling through the wire. The voltage source is going to push you through the circuit. However, when you get to the first resistor, it is going to resist you from passing. Then, when you get to the next resistor, it also is going to resist you from passing. If you think about the whole path that the electron took, start to finish, what was the total amount of resistance that the electron had to pass through? 6 ohms. We are basically adding resistors in series together. We can rearrange the circuit like so. It looks different, but it is the exact same as we had before. These resistors are so close together, they look like one big resistor. Basically, 3 ohms plus 3 ohms is 6 ohms. Now we can solve the circuit. Again, using Ohm's law, we plug in the values, rearrange the equation, and solve. We find that 0.5 amps are flowing in the circuit. If you remember back to the example we just covered, you will find that it is the same example. The first time we looked at a single resistor. The second time we combined 2 resistors and added them together. The outcome is the same in both cases. Some circuits will have many more resistors. In this case, we are looking at 4 resistors with different values. As long as the resistors are in series, or rather the current traveling through them has only one direction to go, we can add them together for a total equivalent resistance. In this case, 14.5 ohms. We label this new resistance Req for equivalent. Here is the takeaway. Resistors in series can be added together. The equation for this is Req is equal to R1 plus R2 plus Rn, where Rn is the nth resistor. Next time, we will look at some components that are in parallel. Take care, everyone.